Good morning, everyone, and thank you to the organizers for inviting me to present today. My name is Martin Willcox. I've been in data warehousing, business intelligence, big data, and analytics for a little over 20 years. And I work for Teradata, one of the leading providers of analytic technology solutions and services. And today's presentation is called Analytics in Action. But we don't have very much time today, so I'm going to kind of skip the normal introductory and level set material that I'd use in a presentation like this. We're going to cut straight to 3 interesting use cases. And then I'll give you a brief perspective at the end on some of the kind of critical success factors around succeeding or failing with data and with analytics. Everybody's talking about the Internet of Things right now, right? Everybody's talking about the Internet of Things, incredible amount of hype. And the current poster child for industrial Internet of Things analytics projects is preventative maintenance based on sensor data, condition-based maintenance. We heard about it from Vattenfall earlier today. I want to give you an example of one such project so you can get a feel for what industrial Internet of Things analytics looks like in practice. Our objective is to apply time series analytic techniques and machine learning to the millions of data points generated by the thousands of sensors that already instrument a modern train to try and identify the characteristic signatures in the historical data that have preceded past failures. If we can do that, and if we can do that successfully, then we can hope to predict future failures before they actually occur. And just as importantly, we can hope to better understand root cause and to improve product design. By the way, the company that runs the express trains, or that supplies the express trains that runs between Madrid and Barcelona, uses Teradata technology in this way. And as a result, the operator of that service is now able to guarantee passengers that they'll never be more than 15 minutes delayed or they get their money back. And this is an example of a phenomenon called outcome-based pricing that the Internet of Things is increasingly making more, is increasingly bringing to market. So much for the business model. How do you actually leverage sensor data to achieve these kind of results in practice? Much of the discussion in the industry right now focuses on the last stage of the process, on the process of creating, building, and deploying a predictive model based on the sensor data. Commentators love to debate, for example, the merits of relatively new techniques like deep neural networks with the performance of established techniques and algorithms like random forest, for example. But in fact, most of the hard work, most of the art happens upstream of the modeling process. Very often, the best modeling approach in a particular scenario is the simplest modeling technique that gives you a sufficiently accurate model. And the real work happens upstream. Sensor data is messy, incomplete, and inaccurate. There's a widespread misconception that because this data is machine-generated, it's more reliable than the data generated by carbon-based life forms. I've got to tell you, that's a complete misunderstanding. Sensors go offline, they're poorly calibrated. There's a whole variety of reasons why the sensor data is very often inaccurate. It needs to be managed. You need to make it fit for purpose before you can do anything useful with it. We're typically going to be using so-called supervised machine learning. That means we need a labeled data set. We need to be able to associate outcomes with the historical sensor data. And that means we need to integrate the sensor data with data derived from operations data and from engineering data. We're going to use other analytic techniques, time series analytic techniques, path analytics in particular, and graph analytics to create features that we can use as input to a predictive model. And then, having gone to all that trouble, we need to try and reduce the number of features so that we can build the simplest possible predictive model. And then and only then do we actually get to build the predictive model. So I think the speaker from Vattenfall talked about a kind of supply chain. You can think of analytics, this kind of analytics, as an analytic assembly line. And the process of building and deploying the model is only the last stage in a complex process that requires other data and other types of analytics, which is why at Teradata we talk a lot about multi-genre analytics. Now, I'm lucky. I get to go to a lot of conferences like this. And I'm always amazed at how many vendors and commentators stand up on stages like this and say things like, the objective of your analytics project is to deliver new insight about the business. Well, let me be very clear with all of you. If the only thing that your analytic project delivers is insight, you have failed. The objective isn't merely to discover something that we didn't already know or to quantify something that we thought we did. The objective is to use that insight to change the way that we do business. And if you don't change anything based on that insight, there's no danger of a return on investment. Now, to deploy a predictive model like this in production successfully, we need to pass two tests. Firstly, the model needs to be sufficiently accurate. These numbers on the left-hand side of this chart, these are real numbers based on a real project. And you can see from the confusion matrix at the bottom that we achieved an 84% accuracy rate in predicting failures. That's pretty good in this particular domain. Sufficiently good, actually, that we spent longer validating the model in this particular case than we spent building the model. But we also have to care about the type 1 and the type 2 errors, the so-called false positives and false negatives. You can see that we also predicted a failure condition in 54 cases where actually no failure occurred. And there are costs and risks associated with type 1 and type 2 errors. The cost, for example, of cancelling a train service or performing unnecessary maintenance on the unit. So we have to understand the costs and the risks of those errors. And we have to understand the tolerance, the levels of those errors that we can sustain. And we need to be clear that the benefit of deploying the model, the return, outweighs the costs. Then we have to be able to deploy the model. In this particular case, deployment's relatively simple. We wait till the train gets to the end of the line, we plug the train in, we suck all the sensor data out of the train, and in particular, the data relating to the engine. We run it through the model, and we can predict failures for the train set. In this particular case, the model is able to predict failures 36 hours in advance, so waiting until the train gets to the end of the line is fine. But you can easily imagine other circumstances where we might need to stream and score the data continuously in near real time in order to make a prediction quickly enough that we have time to action it. And all of these kind of considerations you need to be thinking about when you're thinking about an analytic project. How will I deploy? Can I deploy? My second example is drawn from retail finance. So banks, of course, have always created propensity models to try and establish which consumers they can cross-sell and upsell their products to. And typically, those propensity models have been based on transaction data, they've been based on demographic data, and life event data. These days, of course, more and more commerce moves online. And we've got clickstream and app-based data. We can now see which products and services consumers browsed but didn't buy, which they didn't browse at all, which they got as far as putting in a basket and then abandoned the purchase. A whole series of interactions before the transaction that can teach us a lot about what consumers are thinking and how they're behaving. Can we use that interaction data to improve the performance of these kind of propensity models? Well, the short answer is yes, and now let me show you how it's done. The really key idea here, and this is a really key idea, is that we combine the existing transaction event demographic and life event data with the interaction and the observation data, with the clickstream data, with the social media data. A mistake I see a lot of organizations make is to assume that you should use one source of data or the other. You see organizations that have a big data team using interaction data in the data lake and a regular data team using transaction and event data in the data warehouse. They're not allowed to talk to each other, and they don't integrate the two systems. This is a huge mistake. Both and beats either or in almost every single example that I've seen. Now, there are lots of ways to create features from interaction data in general and from clickstream data in particular, but one of the ways that we've had most success with at Teradata is this idea of path analytics. And path analytics is really about sequencing events, understanding what people do and in which order. In this particular case, the events that we really care about are page views. We want to understand which pages customers who've taken or not taken a particular action have visited and in which order. We're going to use an exponential attribution model to understand the relevance of different pages and the journeys through those different pages to a consumer's decision to do something or not to do something. Armed with that understanding, and with some other simple metrics that we can easily compute from the clickstream data, number of pages visited, time spent on those pages, etc., number of times people have returned to the site and returned to those particular pages, we can create these variables that measure digital engagement. And then we can plug those into the existing model as additional features. And when we do that, in this particular case, the resulting enhanced propensity model vastly outperformed the existing propensity model, at least for the digitally engaged customers. Now, that's not all of them, but in an increasingly connected world, it is most of them. You can see here that the enhanced model is 1.5x more predictive than the existing model. And for this particular financial institution, that translated to an additional 1,500 mortgage sales per month. Both and beats either or. The third example I want to share with you is drawn from the retail and hospitality industries, but actually I think it's increasingly relevant to all B2C organizations, particularly for those of you that start to think about social media, not just as an outbound marketing channel, but also as a customer service channel. You start to see a lot of organizations do this now. Encourage consumers to provide feedback, positive and negative, via social media so that they can understand what customers are thinking and also so that they can take action, remedial action very publicly. You know, as more citizens go online, so-called netizens, and start to provide a commentary about everything they do, and we can mine those commentaries to try and understand how they feel about our products and services, the good, the bad, and the ugly. And of course, we've always been interested in understanding what the consumers think. And if you're in retail, typically one of the ways that you approach this problem was to use mystery shoppers. We send mystery shoppers out to store with a clipboard and a questionnaire, and we ask them to rate their experience, to rate the service, to rate the availability of products on the shelves. Now, there are two problems with that approach. The first is it's based on a very, very, very narrow sample. Let's say we have a convenience store that always runs out of milk at 5 p.m. on a Saturday. But if we only send a mystery shopper to that store once every 3 months and during the week, well, we'd never know about that particular issue. The second issue with that kind of panel data is it's typically only available sometime after the fact, right? We have to send out a bunch of mystery shoppers, we collect and aggregate and normalize their data, and then a report appears on somebody's desk weeks or even months after the survey was taken, often too late for the insight to be actionable. By contrast, if we're looking at social media data, that commentary provided by netizens, well, that's available pretty much instantaneously and in many cases at marginal cost. And because millions of consumers are providing a constant commentary all the time, instead of a very narrow sample of data, we have a huge corpus of information. A huge corpus of information that we can apply text analytics to so that we can build topic models to understand which things consumers are talking about, and then build sentiment models on those topic models so that we can understand what they're saying and how they feel. This is an anonymized version of an actual project we did with a big US organization. And you can see that we were able to score sentiment on a variety of topics by location. So in this particular example, orange is net positive sentiment and blue is net negative sentiment. And you can see that the consumers of this particular chain, they're broadly pretty happy with the service that's provided, but they've got specific concerns about assortment, location, and price, and in particular locations. And not only that, but in this case, we were able to identify statistically significant correlations between these sentiment scores and store financial and operational performance, which means that we can not only understand what customers don't like, but we can quantify the financial impact so that we can prioritize which issues we need to address. Okay, So let's change gear slightly. And let's talk a little bit about critical success factors. You know, we're very lucky at Teradata. We get to work with some of the largest, some of the most analytically sophisticated organizations across the world. And because we provide more than just technology, we also get to work with our customers in very many cases throughout the complete analytic life cycle. And that means we get to see a lot of really good practice. And also, every now and again, some less good practice. So I want to give you some personal observations based on what I've seen in particular the last few years about what differentiates successful data-driven organizations from less successful organizations. There's a huge amount of hype at the moment around machine learning. I also was at the Gartner conference earlier this week, and I think the Gartner guy said that the only thing that's more hyped than the Internet of Things right now is artificial intelligence and machine learning. And a lot of that excitement, to be clear, is absolutely justified. Some of the new machine learning techniques, deep neural networks, for example, already vastly outperform some of the existing techniques for problems like image recognition. And Gartner certainly this week were predicting that best-in-class approaches to fraud detection and to demand forecasting and preventative maintenance would all utilize some of these new techniques, deep learning in particular, by the end of 2019. Now, of course, we won't know until the end of 2019 or maybe a little bit afterwards whether that prediction is right on the money or whether it's wildly aggressive. But what we can say with absolute certainty is that every single analytic technique ever devised is associated with a particular set of trade-offs, a set of trade-offs that make it more or less relevant for a particular use case. And a big part of the art of analytics is matching the right technique to the right use case, rather than trying to turn everything into a nail for each new shiny analytical hammer that the industry and the academia gives us. There'll be some use cases where the additional accuracy of things like deep neural networks is absolutely something that we need and we value, and it will outweigh the additional cost and complexity of those approaches. And there are other situations where transparency is really important, where we need to be able to explain not just what the model has predicted, but why the model has predicted it to a whole range of senior stakeholders, including potentially the regulator. Also understand that you simply can't machine learn everything. I had a number of customers last year that would invite me in to speak to their C-suite, and they said, but please don't talk about analytics or data science, because we've told these guys we're going to machine learn everything. We don't want you to make us look bad. Listen, you can't machine learn everything. And even if you could, for some problems, there's just a quicker route to goal. The big web properties, typically, they don't try and predict what size, what color, and which part of the page to put the Buy It Now button on. They just run 100 A/B tests instead. They measure what works best, whether treatment A is more effective than treatment B. And then they know whether that treatment is more effective for a particular customer segment, and they have a measurement that they can compare forwards and backwards in time. So the best and the most successful data-driven organizations start with an understanding of the problem that they're trying to solve, then think about the data that are available to them to try and address it, and only then move to selecting tools, techniques, and algorithms. Understand also, and this might be slightly surprising coming from a representative of a technology vendor, but technology and architecture is a critical enabler, but it's only one component, and it's arguably not the most important component. There's been so much advance in the technology recently that some of you are seduced into starting with the technology. And that's almost always a mistake. When you start with the technology, you will almost always end up with a brittle, inflexible architecture that's difficult to change and that increases the time to market for new analytics, when what you want to do is decrease the time to market for new analytics. You have to think about how analytics is going to change the way you do business. As one of my former bosses told me once when he was rejecting one of my project proposals, he said, "Martin, you've taken an old process, you've added expensive new analytic technology to them, and I'm sure you'll tell me it's not expensive, Martin, but in the end, all the technologies are expensive, even the free ones. And you've just made an expensive old process. You haven't changed anything. We have to think about what we're going to change. Instrumenting your systems and processes costs money. Integrating that data costs money. How are you going to use the insight to make that product or service better from your customer's perspective? How are you going to leverage that data to improve the efficiency of your own operations? And if you can't answer that question, stop the project until you can. People and organization, absolutely critical in all of this as well. Cultural and organizational factors are really, really important. Most of you report that you don't have enough analytic resources to do all of the projects that you want to do. So making sure that the resources that you do have are as engaged as productively as possible becomes a really, really critical concern. And not every analytic innovation and experiment that you run is going to be successful. So rewarding teams for pushing boundaries rather than punishing them when they come up short is also really important. My colleague Zanor Tariq is going to be speaking this afternoon in more detail about cultural and organizational factors around data science. Lastly, this is the personal checklist that I use when I'm starting a new project, and I highly recommend it to you. Make sure that your project is aligned with an important business objective. If it isn't, you've got no chance of getting organizational support, and if you have no organizational support, it doesn't matter how brilliant your work, it won't pass the so what test, and it will never be implemented. Make sure that it's feasible. Understand what data you've got. Can the data support your objective? If they can't, change your objective or get some better data. And especially in large organizations where analytics is a line of business concern, make sure you reach out to all the other groups that are working to try and understand, has anybody done something like this before? Make sure you leverage that learning and de-risk your initiative wherever you can by doing a quick and dirty prototype. Much better to learn that a particular approach isn't relevant to a particular use case after 6 weeks than after 6 months. I see my colleague standing here by the stage, which I imagine means I'm about to be evicted. So thank you very much indeed for your time and attention today.
Thank you very much, man.